Right, a very good morning. This is coming right after the opening acts, so it's a tough one to follow through. Uh, I hope everyone's wide awake and excited about AWE in Singapore, as I am. My name is Vinesh. I will be the moderator for this session in the morning. We have a wonderful title, which is The Future of XR in Education. And with me are two experts, if I may call them, but they're more than that. They actually are very distinguished personnel from different backgrounds. Yeah. So I've got Professor Habib, who's a visiting professor from MIT, and he comes with that in-depth research, teaching, pedagogy, and a whole wealth of experience in education. And alongside with him is Mr. Warren Russell, who's from physics, and he comes with that wealth of experience having been engaged in engineering products to support XR. And the blend of both of them being on stage today with me will have more insights into the future of XR in education and how that game is changing as we speak. XR in education is very straightforward. We use XR in the form of blended learning. We use XR in terms of the immersiveness that we want to send the message across from an educator to a learner. And XR has basically revolutionized teaching and learning. It has set a different pace towards the speed of learning, and the adoption of XR has taken many different steps over the last couple of years. I myself am an educator, researcher, and innovator. I built the first one-of-a-kind XR studio in Asia, where there aren't any like it in Asia at the moment. And that experience has brought me to this stage whereby now I know that this is here to stay. But for how long, and how do we cultivate the usage of XR in education? Now, to get the ball rolling, gentlemen, I've got questions for you. Let me shoot the first one to Professor Habib. And please do introduce yourselves. I gave you a light introduction. Go ahead and introduce yourselves in more depth. Professor Habib, how have you used XR recently for teaching and learning? Because that's the core usage in any form of education, whether it's from kindy all the way till tertiary. Tell us a little bit about your experience in teaching and learning using XR.
Thank you very much, Prof. Vinesh, and greetings to everyone. It's an absolute pleasure to be here. Greetings to Warren, and thank you to the organizers for having us. So I think our first use case with XR goes back to 2021. Around the globe, we had a hard lockdown with COVID-19. And during that time, a lot of our students who are studying exercise physiology, we have a background in sports science and exercise physiology. That's the area that I mainly work in. They were not able to come into the lab. And so the third and fourth year syllabus was almost disrupted. And so we had to look at different approaches of how do we integrate these kinds of learning so that this disruption doesn't halt them from graduating or from graduate attributes. And we looked at a form of simulated-based learning, SBL, and one of the forms of simulations at the time was virtual reality. So we basically created a game and we ported it onto virtual reality. And the main area here was not to replace what they would do in a lab with patients or with athletes, but was mainly to focus on clinical reasoning and skill acquisition. And we're now starting to find, 4 years later, that skill acquisition is just at the top of the iceberg. But when we go more deeper at the bottom, we start to understand that we're actually tapping into the learner's state of an embodied cognition. And when you are able to tap into a learner's embodied cognition, you are then able to look into the process or pedagogy of the process of becoming. Becoming orientation is critical. So for a medical doctor, a lawyer, a chartered accountant, anyone who wants to become an expert in something, VR is right at that center phase in order to augment their learning and their transformation of how that can come into the real world. And so it's certainly one of the key enhancers that we find, not just in the health sciences, but throughout, of how it really is a key informer of integrating embodied cognition, skill acquisition, and optimized decision making. The second project, very briefly, is we're focusing on sports training. We're using XR in the sports aspect. Can baseball batters or cricket batters or tennis players optimize their swing, optimize their training? I think it has more for a role in psychology and anxiety and pressure control, where you are immersed into a stadium of 50,000 fans shouting at you, and you've got to basically adapt to that kind of environment. So we're having that kind of use cases, and we're looking at biomechanical cues, performance patterns, pattern recognition, markerless motion capture, and we're integrating a number of computer vision integrations with virtual reality to determine how do we optimize training and performance for athletes or high performers specifically.
Oh, very interesting. I picked up pedagogy, decision making patterns, and also use cases that you use to sort of describe content and knowledge. And that's, in the immersive world, more impactful towards learning. And you've described that very well. We want to move on now to the next part of the impact of XR, especially spatial computing. Warren, I want to reflect back to 2025, because this is ever evolving, right? We're now in 2026. What happened across the XR industry in 2025 in terms of hardware and the OEMs, and how did that shift the adoption process in education moving forward into 2026? I hope you got me there.
Yeah, I did. First off, thanks for inviting me to be on stage with you today. This is my first time in Singapore, and I'm very happy to be here. I'm Warren Russell. I do business development and partnerships for Vuzix's OEM division. I've been in the industry for 10 years across VR headsets, smart glasses, and now more recently, optical designs, and working with different companies to make their vision come through. And your question on what happened last year, AI basically dominated the narrative in our industry and basically overshadowed everything spatial computing. From my perspective, this was a healthy pullback from the spatial, and AI has given a much needed discipline to the industry. And everyone's moving forward in the right direction now. Technology stack has matured overall. Display engines, manufacturability of waveguides has also greatly improved. Big credit to Meta with taking the risk on their audio glasses and now the Meta Ray-Ban displays. Demand is very high. So the education tends to follow what enterprise does. And the trend is that glasses must also double as a fashion accessory. That's a trend that was defined in 2025 and will be for the rest of time.
Right, so the trend was set in 2025, and I like the statement you made. Education should follow the hardware being produced rather than education being the driver towards hardware being produced. And I think that's true, because the hardware is not only for education, it's across the whole spectrum of usages. Now, there's another element in education which is very important, which is R&D, research and development. So you got teaching and learning covered earlier. And in R&D, Professor Habib, you're a mastermind in a lot of R&D work that you have developed outcomes using XR technology. Maybe share a couple of the outcomes that you have achieved.
Thanks for that. Wouldn't say I'm an expert just yet. We're still at the nascent stage, and there's a lot more questions we're starting to ask and that we want to answer. But I think as a low-hanging fruit where we are right now in the last few years is that we're starting to find one of the key outcomes in terms of VR really being centered around decision making. The previous speaker spoke about how wetware taps into those particular neurocognitive markers or metacognitive markers, which is really important and imperative. And so when you're looking at aspects of, say, anticipation, interpretation, decision making, reasoning, skill acquisition, all of those kind of aspects is something we've already identified as key outcomes from our research. Whether we're looking at it from higher education for exercise physiology or medical students, or whether we're looking at it with regards to high performers or athletes, we're finding that there's a common thread. But I think for us right now is about really tapping into that space a bit deeper and understanding to what extent are those metacognitive markers being achieved, and how is that now translating onto the field? Because we cannot apply a blanket approach to what's happening in training or simulation and then to say it might happen in the match as well. Just like any other kind of periodization plan or training that's being manifested, simulation or the aspects of XR is in a very similar way. So in the context of training pilots, they would be able to be trained for a variety of particular scenarios when they're in the air. And that's exactly the same that we're finding now with athletes. We can use it to allow them to have readiness and to feel less pressure and to cope with anxiety a lot better, and for us to understand their motion mechanics and how they're training and to give them AI feedback. So all of those things can be done. But at the end of the day, it will never be a fully 100% customizable replacer to what really needs to be done in practice. And I think that's where humanity and technology converge. R&D is really at the center of technology, but the person is, or the people that we're working with are at center stage. And I think that convergence of technology and humanity is absolutely critical when it comes to an R&D perspective. When it comes to hypothesis testing, when it comes to putting forward questions that are important to how you're going to address this question methodologically and what kind of outcomes, implications could arise from this, I think it's very important to keep in mind that it's the humanitarianism aspect or implication that we've got to keep at the back of our head when disseminating this kind of knowledge or when testing particular research paradigms. I mean, one quick example I could share is in the context of Sully, a true life story, about 15 years ago when he landed the plane in the Hudson River. And they ran a number of simulations to determine if this would have happened differently if he turned back and landed on LaGuardia Airport. But when they reran the simulations and accounted for that 5 to 10 seconds delay of decision-making or anticipation, they found that their pilots who did the simulation again would have actually hit one of the nearby buildings because they would have been on a lower terrain. And so when you look into aspects of pressure and humanity and you're looking into those markers, you've got to take that into account in a research and development kind of area, because those are the kinds of things you've got to think about. It's not just about what's significant, what's the difference between X and Y, where are the Z coordinates. All of the stats, data science are well, but the translational research impact for R&D at this stage for XR is absolutely critical. And that's what we're finding both in the United States and our work in South Africa.
Oh, wonderful. Keyword there, humanitarianism. And I think that is an important element in XR development. The key thing there is R&D and XR, they coincide, of course. But then there is R&D done for the hardware plus the applications. But then again, there is also R&D done using XR as in terms of a variable in developing that outcome. I think in simple terms, if I use healthcare, to add on to the examples you've given, in the last 4 decades, healthcare has gone on potential doctors doing clinical on actual bodies, to dummies, and now to virtual bodies. And that's been a revolution, and that's now a bit more cleaner, a bit more precise, and definitely taking the whole education for doctors in the coming future to a different level of expertise, to reach their skill sets. Now, in terms of XR, there's always this notion that XR is expensive. and it's ever evolving, which means that every year you've got to invest on new technology, new hardware, software that comes with it. And Warren, you know what I'm talking about in terms of adoption of XR and the cost that comes with it, because I myself face this impact every year. And every November, I ask my guys, what do I need to spend on next year? This is the scenario that I want in terms of outcomes for the next 12 months. What do we need to do in order to get ourselves to that outcome? And what do we need to invest? And what's your take on the perception that XR is too expensive? Is it something that we should be putting onto our budgets in education, R&D? And or is it just an instructional tool? We stick to what we bought and we just continue to use it, let it take its wave in terms of the evolvement, but we'll just stick to the old tools that we have. What's your take on that?
Yeah, it's a good point, Vinesh. XR glasses are first and foremost a productivity tool for enterprise and education. So you have to get some kind of value out of it. Usually it's going to be tied to efficiency gains, time saved, and combined with, do the people actually like wearing it? Because no matter what you get in a small sample size demo, if no one wants to wear it for more than 10, 15 minutes, that's basically a sunk cost. So you should get value out of what you're doing. If you're not, then there's something wrong with the problem you're trying to solve or the way you're trying to solve it. The hardware should pay for itself pretty quickly in outcomes of the measurable ones that you're looking for. And the good news is prices of hardware is coming down quite a lot as manufacturability improves. Yeah, is that answering it?
I think that's a true fact. It's coming down. Anything new is always expensive in the beginning, right? And then when the users increase, then prices of hardware have actually come down. And you know, in education, spatial computing and XR, for that matter, is a new scenario. It has come into a more heavy usage, especially since COVID-19, so since 2020. And that's what Professor Habib also mentioned, since 2021. And that's where it took its scaling up in terms of adoption. But there are a lot of users for XR. We talk about the experience. So the immersive learning experience ties into the experiential learning that every student or learner gets to experience. And along with that is also retention. As we move ahead in education, especially with the insurgence of AI and what is AI impacting education, ChatGPT and all that, is education still relevant? But if you can have adoption of XR in education, it gives them that new wave of learning. And it allows people to still embrace education as something that needs to be part of their life. Now, as a rapid fire towards the end of our session, what are your thoughts moving into 2026 and beyond of how XR can bring that impact towards making education still a necessity in the lives of the youth? Start with Habib. Yep.
Yeah, I think it's a good point that the manufacturing costs are going to, it's going to help bring the cost down, because I think one of the key points we're concerned of is accessibility to a broad range of places that really need this technology. I mean, when we talk about smartphone adoption in education, at the one time looking at mobile apps for learning 10 years ago, a number of our students or universities, especially in South Africa or in low to middle income countries, did not have access to these technologies. So for me, that's a very positive sign, and I'm hoping that could broaden the bandwidth around accessibility to many countries who really need it. And I think the second thing, which coincides with the AI point around education, is that I think education is in a very prime spot right now, provided that educators and universities and institutions really prioritize the educational theories of critical thinking and constructivism. Because if they're going to be using it for anything that they want to get done, then we're not really creating critical thinkers. But AI can certainly, we've seen many policies right now, and we're sitting on committees right now of how this is basically shaping, potentially breaking certain aspects of dissertation writing, promotions to full professor, committees. I mean, we're sitting on a number of these. But the most important message is that we really need to foster the integrations of critical thinking and constructivism. Because when this is done, not just within higher education, but when this is translated into the workplace or even in industry, we're finding that even engineers or the design thinking philosophies start to take shape and rise because they've also embedded this kind of thinking around critical thinking and constructivism. And with those leading theories, we start to see that that would be the best way to marry AI and education, especially in a higher education context. So I think those 2 points for me is the most important thing right now with XR in education. It would be accessibility and the application and adoption of critical thinking and constructivism to really optimize success for XR in higher education. Thank you.
Nice. Warren, your thoughts on 2026 and beyond?
Yeah, I think XR is going to be a core education tool in the future, and it's going to be good for 2026 and beyond, because XR and AI are basically merging into one. And what does that mean? It's the AI's basically be watching what the person wearing the glasses is wearing. It'll understand the intention, and the XR side can provide context and the overall user experience. Those two things combined, especially in education for trades, skills-based learning like trades and healthcare, it's just going to be a better tool of how they learn and retain information in real time. You get real-time feedback, and it's going to be personalized. That's actually a big key thing to acknowledge. You're going to get personalized feedback from your agent that lives in the glasses, and it will share information to you through XR. And the wearability needs to be there, first and foremost. Otherwise, people are just not going to wear it. But yeah, so that's where I think it's going in 2026 and beyond.
I like that point on wearability, because I had this sort of motion sickness when I first wore those glasses or any headset, but I got used to them. And I think the design of headsets are changing as well. Not only are they becoming cheaper, but they're also becoming lighter. And I think that is very important in the digital transformation that XR is playing in education. Immersiveness, the whole experiential learning, the whole sensory adoption into education. It allows for, as what I said earlier, retention. Gentlemen, what you gave me and the audience this morning was insights to XR playing that important, pivotal role in education moving forward. As I said, making it still a necessity, still an environment within classrooms, auditoriums, within a campus, within a school, for that matter. It will allow for students to still be interested in knowledge transfer and make the streaming of the adoption and the learning of all content even more impactful. Ladies and gentlemen, XR is here to stay. XR has definitely got a future in education. 2025 was a real impactful year for education. 2026, as my two panelists have mentioned, it is going to take a different round of impact from the hardware side, from the user side, and more things to come. Education is very important. It is the foundation of anything that we do. XR started with education. Thank you, gentlemen, for being part of the panel this morning. It's a pleasure being on stage with you guys. Thank you, everyone. Have a good day and enjoy AWE.